Alright guys, welcome to the Experiment 7 copper cycle calculation video. For this particular calculations, I'm not going to go over a lot of it. There's actually not many calculations for this, but I am going to go over that second net ionic equation. I did go over the first one in the pre-lab chat video if you do want to check that out. So for this first, or the second, net ionic equation, and this is on page 12, I believe, we have this copper cation complex, which I'm just going to leave as this because this is the whole compound if we were to write the aqueous form. And we're adding that sodium hydroxide, so NaOH, and this is also aqueous. And for this one, we're looking for what is that product B. And we also have that NaNO3, which is also aqueous. So if we briefly look at this, we'll notice that what we actually have happening, so we have this sodium and we have this NO3 coming together, is odds are we have some sort of double replacement reaction coming. And what that means is we know that the positive charge of this is going to replace the positive charge of this one. So I'm just going to rewrite this and break those aqueous solutions up. So we have copper 2+, and that's aqueous, plus the 2, I'll actually write that, so 2NO3, and that's aqueous, and these are minus, plus we have an Na plus aqueous, plus an OH minus aqueous, and that is going to give us our product B, which we can tell, so this is actually going to be a blue solid. So whatever it is, it's solid. Plus we have Na plus aqueous. I hope you guys can see, sorry about that. And we also have NO3 aqueous, and this is the minus. So, and let me try to scoot back so I can get it all in frame. So what we're actually looking for here is we're looking, okay, what is actually happening? So we know that it's not going to be the copper nitrate compound, because that's what we had to begin with. So that means that our positively charged is going to match up with our negatively charged, and these ones are going to come together, which is what we're seeing over here. So that's why we're calling it a double replacement, because the positive charge over here is switching partners, if you will, with that negative charge of the other reagent. So if that's the case, we have copper coming together with hydroxide. Now because copper has a 2+ and OH has 1-, that means that we will need to have a 2. And this is solid, we are given that. So that means that product B is going to be this copper hydroxide product. So copper 2 hydroxide. And when we're actually going through and looking at the net ionic equation, and I'm just going to leave this down here for now, we know that our copper is going to be only on one side. We have this NO2 that we can get rid of on both sides, and we have this Na plus that we're able to get rid of on both sides. So when we're actually condensing down our net ionic equation, we can say that we have copper cation, copper 2 cation, plus 2 hydroxide ions is going to yield this copper hydroxide solid. So that is how we're going to be able to solve that net ionic equation there. Now the other major thing that this experiment actually tells us to do is the percent recovery. So percent recovery is going to be the amount obtained at the end of the experiment divided by the amount started with. Times 100. So if we notice, our percent recovery, we're actually determining the percent that we started with that we were able to bring through all of those different steps. And I'm just going to quickly, we're going to look back at this. So when we have all of those different steps, we are probably going to miss some. We might not be able to add enough of one thing to react all of it, or maybe there was some precipitate that wasn't able to go into the next equation. And I want you guys to think about those different things. Some of the things that aren't error would be something like a scale or a balance error or something like that. So I want you guys to really think about that. The other thing that isn't a source of error at all are calculations. So when you are discussing the sources of error, I want you guys to think about something that may have happened or some product that may have slipped through on something similar to that. The other helpful hint that I wanted to just point out, and this is actually for our first genetic equation, is I want you guys to think about what might still be on this other side if we add too much acid before we actually have that progress. So we'll notice that we're adding acid. So if we have more acid, we might still have some H plus hanging out. And that's not something that has to be in the net ionic equation, but it's something that's important to think about. If we have H plus and we're adding a base, NaOH minus, in that second step, what reaction might occur before we're actually going on? And if we think about it, if we have some extra acid and we are adding some base, odds are we'll probably make some water before we have this OH actually react with what it's supposed to. So in this case, it would be that copper 2+ anion. Okay, so that's just a helpful hint for that particular experiment. As far as everything else, I think it is all right there. If you do have questions or comments, please feel free to contact your TA. We are doing the best that we can in this particular situation. And if you are interested in meeting face-to-face virtually, please let us know, because we are more than happy to meet with you to kind of get things sorted through. I know it's not always the easiest to ask math questions or things like that on via email. So happy doing experiment number 7. I really urge you guys to look at Travis's video to actually go through all those steps as well. And stay safe, guys.